Hi everyone, in this video I will explain about continuous random variable. In the last video I explained the discrete random variable. So first now I will start with the small part that compares between the two random variables. So random variables are divided into two types: discrete random variable and continuous random variable. The discrete random variable, so the values of x are countable, so I can count them, I can list them, so in summary they are distinct or separate values. The continuous random variable, so x can take any value in an interval. So obviously I can't count them. I can't count them. For example, x can take values that belongs to interval, for example, 0 and 2. So x can take any value between 0 and 2. For if I put them on this axis, 0, 2, for example, I can select this value here, which can be, for example, 0.925, whatever. So obviously I can't count I can't count all the values between 0 and 2. In this case I call x as a continuous as a continuous random variable, whereas x, if it's discrete continuous random variable, for example, x equal 1 if the result is head, 0 if the result is tail. This x comes from an experiment, for example, tossing a coin only once. I'm interested in the number of head obtained, so the result can be either head means 1 or tail means 0. In this case I can count them. I can count the values of x, can be 1 or 0. I have two values, first value and second value, and I can list them 1 and 0. On the other hand, the continuous random variable, it's impossible to count all the values in the interval. For example, I have interval 0, 2. Is it possible to count all the values between 0 and 2? Of course not. Therefore, it's continuous random variable. So what I need for a continuous random variable in order to continue with the probability calculation of all this and also the parameters that I have to calculate them, like for example the mean, the variance, and deviation. In continuous random variable, I need a function known as probability density function, as acronym for it, PDF. So in order to define a continuous random variable, I must define this function. And there are two conditions must be satisfied to call this function probability density function. The first condition, f of x must be greater than or equal to 0 for any x for any x belongs to set R. The second condition, the integration of f of x between minus infinity and plus infinity must equal to 1, which is the total, okay, probability. As we mentioned before, in discrete random variable, the total probability must be equal to 1. Same thing in continuous random variable. The function f, to be a probability density function, also need to have the total probability, okay, must equal to 1. Okay, so I can ask you for this part a question. For example, I give you the function f, and I ask you to see if x is a probability density function. If I ask you this question, in this case, you have to verify these two conditions. Okay, in the lecture note, okay, I gave you an example, okay, which is defined, okay, as f of x, for f of x, which is equal to, let me write it in here, okay, that's the example, okay, f of x equal to 1 if x between 0 and 1 and equal to 0 elsewhere. Okay, say for example, if I ask you to verify that f is a PDF, means probability density function. Okay, as I mentioned before, f to be a probability density function must satisfy the two above conditions, first one and the second one. Okay, so what I suggest on you, always plot or trace the line, the x-axis line. Since I'm talking about one variable function, okay, always trace this line, the x-axis line, and put the interval, as I mentioned also before, that continuous random variable must be defined, okay, on an interval. Okay, so in here it's defined on 0 and 1, so I put 0 and 1. On the right hand side I will go to plus infinity, on the left hand side minus infinity. So when I put this line, the x-axis line, so as shown in this function, f equal 1 for x between 0 and 1. For x between 0 and 1, f equal to 1. So in here, f equal to 1. Elsewhere, it's equal to 0, which means in minus infinity, for x between minus infinity and 0, and x between 1 and plus infinity, f equal to 0. So in here, f equal to 0 and f equal to 0. Okay, so this line, okay, makes for us the solving the problem, make it easier for us. Okay, so now I have to verify first the first condition, okay, which is I have to show or to verify that f of x greater than or equal to 0 for any x belongs to set R. So this one I have to verify it. Okay, so in this example I can split, okay, x into 3 intervals, okay, 1, 2 and 3. Since I'm talking about x belongs to set R, it means x between minus infinity and plus infinity divided into 3 intervals, 1, 2, 3. For x between 0 and 1, for x between 0 and 1, f of x equal to what? Equal to 1, greater than 0. True, okay? Because I'm verifying that fx greater than or equal to 0. The first part, it's true, okay? So that's right. So the other two intervals, minus infinity 0 and 1 to plus infinity, I have f equal to 0. Okay? And here, for x less than 1, less than 0, and x greater than 1 for x less than 0, this part, and x greater than 1, this part, f is equal to 0. F of x equal to 0, which is greater than or equal to 0. That's right. So the two parts, okay, are true. Okay. In this case, I already verified that for any x belongs to minus infinity or plus infinity, this one same thing, set R. Okay, I have f of x greater than or equal to 0. Okay, so the first condition is satisfied. The second condition, I have to verify that the total probability is equal to 1. I do the integration for f of x. The second condition, verify minus infinity plus infinity fx dx must equal to 1. Okay, so I have to verify it. As I did before, okay, trace the x-axis line, okay, minus infinity plus infinity, the interval 0, 1, f equal 1, f equals 0, and f equal 0. Okay, the integral between minus infinity and plus infinity fx dx can be written as following. Okay, from minus infinity to plus infinity, I can divide it into first interval, second interval, and third interval. So minus infinity 0, minus infinity 0 fx dx plus 0, 1, 0, 1 fx dx plus 1 plus infinity, 1 plus infinity fx dx. So now I divide this integration into 3 integrals. Okay, 1, 2, 3. So when x between minus infinity and 0, f is equal to 0, mean the integration is equal to 0. When x greater than 1, f is equal to 0. This one is equal to 0. It means the integration is equal to 0. For x between 0 and 1, x between 0 and 1, f of x equal to 1. So I replace f of x by 1. So now it's equal to 0, 1, 1 times dx equal, okay, the integration of 1 is x between 0 and 1, it's equal. So I replace, first time I replace x by 1 minus, then I replace x by 0, so it's equal 1 minus 0, it's equal to 1. That's true. Okay, so now I verified the second condition. So the two conditions now are verified, the first one and the second one. In this case, okay, so condition 1, it's true. Condition 2 is true and verified in this case. So I can conclude, okay, f is a PDF. Okay, so in this example I show you how to verify a function is a PDF, probability density function. The only thing you have to do is to demonstrate or show that f of x greater than or equal to 0 for any x belongs to set R. It means for any x between minus infinity, okay, and plus infinity. In the middle here, you put the points shown in the function. Okay, so you put only the points shown in the function here. So 0 and 1. So you put them on the x-axis. Okay, 0 and 1. So in this case, I divided into 3 parts. 1, 2, 3. Okay. The same thing I do it for any example. In this example, the value Okay, the values of f of x are only divided into two parts, 1 or 0. It can be more than. It can be, for example, 0, 1, 2, 3, and 4 different intervals. Okay, so now I will show you how also can I calculate the parameters that I can ask you for. For example, calculate Ex, Vx, and sigma x. So I follow the same, okay, the same approach followed before in integration. The formula of Ex is sigma, integration between minus infinity plus infinity x fx dx. So I do here the same work as before. I did the integration before, minus infinity plus infinity for f of x, but now I multiply f of x by x. If I want to compare this formula with the discrete random variable, and discrete random variable, it's Ex equal summation, okay, xi pi, okay. See, the summation now is integration, okay. Why? Because it is continuous, okay, random variable. So I have to do the summation of continuous domain, okay. So that's the difference. That's the difference between them. So how to work on this? As I did before, put the x-axis line, minus infinity, plus infinity, 0, and 1. Here f equals 0, here f equal 1. This is for the same example, and here f equal to 0. So the mean can be written now, as I did before, divide or split this integration into three parts. Part 1, part 2, and part 3. So from minus infinity to 0, plus 0 to 1, plus. So in here you have to write fx dx, fx dx, fx dx, okay? And the last part, 1 plus infinity, okay? So between minus infinity 0, f is equal to 0, means the integration is 0. 1 plus infinity also equal to 0, I mean the integration is equal to 0. So the only part left is between 0 and 1. So in this case, 0, 1, x fx dx. Between 0 and 1, f equal to 1. Okay, so 0, 1, x times 1 times dx. So it means I have the integration of x dx. It's x2 over 2 between 0 and 1. So in the first time I replace x by 1, minus, I replace the second part, okay, minus, I replace x by 0. It means it's equal, the first time I replace x by 1, it's 1 over 2, minus, okay, 0 over 2, it means equal to half, okay, equal to 0.5, okay. So this is how I calculate, okay, the mean. Now the variance, it's a bit similar to before, okay. Vx, the variance is equal. The variance is equal. That's the formula for it. The same thing in discrete random variable, but instead the summation I use the integration. Okay, minus infinity plus infinity x2 fx. In discrete random variable I put xi square px. Okay, pi dx minus, same thing, minus mean squared. Okay, so this part I do the same work as before. I divide it into three integral. Okay, integration minus infinity 0 plus 0 1 plus 1 plus infinity. Okay, so this part is equal to 0, this part is equal to 0. So the only part I have to work on it, this one, it's mean between 0 and 1, x2, f is equal to 1 times 1 dx. the integration of x2, it's x3 over 3 between 0 and 1, 1 over 3 minus 0 over 3 equal 1 over 3. Okay, this for the variance. I didn't finish yet. So Vx is this part minus Ex squared. So now it's Vx equal 1 over 3 minus 1 over 2 square, means 1 over 3 minus 1 over 4. Okay, I calculate the value. Okay, standard deviation. Standard deviation, it's always the radical of Vx. Okay, square root of Vx. Okay, in this example, I explain, what is the continuous random variable, what I need to work on it, I need a probability density function, how to verify it, and how to find the parameters for it. So now, if I ask you to calculate, for example, the probability between any two values, say for example, I want the probability of x between minus 1 and 0.5. Okay, and this type of work, I mean continuous random variable, always you have to use the integration. So you have to do it as following: between minus infinity 0.5, you put it as like this: minus 1 0.5 fx dx. Okay, it's equal to f. Okay, in this case, you have to also divide the integral into two parts: minus 1 0 plus plus 0 0.5. In this case, this part is equal to 0. Between 0 and 5, fx 0 and 0.5, fx equal to 1, means equal to 0.5 dx equal x. Between 0 0.5, it's equal to 0.5. So this is a simple example how to calculate the probability. So this one is now a straightforward example how to calculate the probability. In the next video, I will explain for you how to find the cumulative distribution function, f of x, that makes easier calculation for a probability. So instead of doing each time the probability as following to find the answer for this example, so the only thing you have to do later on, so for example, which is equal to probability of x less than or equal to small x. So this one I will show you how to do it in the next video. Thank you very much.